Hello and welcome to helpyourmath.com. In today's video we're going to be covering part 2 of the exponential properties for rational expressions in a continuation from the part 1 video. In this case, again, we're going to simplify the following completely using the properties of exponents, and again we're going to express our answers with only positive exponents. Alright, since this is the second video, we're going to use a little bit of the properties of exponents only. We're not going to use anything basic to do this. We're going to use every property we talked about before in continuation. So let's begin with the first of the series of 4 problems. So we have here 5x to the second power times y to the negative third divided by 2x to the sixth power y to the fifth, all in parentheses raised to the negative second power. So again, we're going to follow the best techniques to solve these using the properties of exponents. So the very first thing we're going to do in this case is work with the inside of the problem. And then we'll deal with the outside exponent, because in the order of operations we're dealing with the insides first. Now sometimes we'll have different methods for doing different things, because for the problem particularly there may be a faster way to get to the solution. I would still advise that you continue using what makes you most comfortable. Alright, let's begin with this. So the first thing we're going to do in here is we're going to solve the insides of these, right? And to do that, what we're going to do is we're going to simplify whatever we have. So let's start with the inside of the parentheses here. We have a negative exponent. We want to transpose that to the denominator. So we're going to have 5x to the second power. And in the denominator we have 2x to the sixth. And the negative third power is going to come down. So we have y to the fifth times y to the third. This is to the negative second power. The next step is to basically multiply these two and add the powers together. So we have 5x squared over 2x to the sixth y to the eighth. When we multiply common bases, we add the exponents. 5 plus 3 gives us this 8. Now in the next step we want to simplify these two. And since the exponent of the denominator is greater than the numerator, we're going to subtract 2 from the denominator's power. And to do this, we're simply just moving the x to the second to the denominator. So what's happening here is we get 5 over 2x to the sixth minus 2 y to the eighth. And this is still to the power of negative 2. Now let me just go over what's happening here, all right? So here we have x to the power of n with x to the power of m. Usually the division rule is to take the numerator's exponent and subtract the denominator's exponent. But this is only the case if the numerator's exponent is greater than the denominator. In the case that the denominator is greater than the numerator, what we get is the same rendition, just instead of being a numerator, it's a denominator. And what this does is, this is in the case where n is greater than m, and this is in the case where n is less than m. Right? If they were even, they just simplified to 1. Now the point behind this is so that we get a positive exponent. And here when we do 6 minus 2, we get 4. If we did 2 minus 6, we'd have negative 4, which means we have to move it back to the denominator. In this case, we don't have to worry about that, right? So let's continue with this problem and speed to the end. So now here we have 5 to the raised 5 over 2 x to the fourth power y to the eighth to the negative second power. The last step we have is to reciprocate everything because of the negative exponent. So the negative reciprocal, when we flip this fraction, we're going to have the 5 on the denominator. We're going to have 2x to the fourth y to the eighth on top, and this becomes a positive 2. So now we just do the perfect square. We raise everything to the second power. 2 squared here is going to give us 4. X to the fourth, the exponents are going to multiply, so we have 4 times 2 for the exponent of x, which gives us an 8. And then we have y to the eighth times 2 becomes y to the 16th, all over 5 squared, which is just 25. That's our solution for the first problem. So I'm going to take this and lay it up here again. So we have 4x to the eighth, y to the 16th. This is all over 25. Let's move on to the next problem now. All right, continuing on to the next problem, which is number 6, we're going to have 5xy's. So we have here 5xy's over 2xy cubes to the negative second power. multiplying against 6xy to the third over 5y to the fourth power to the power of 3. Now here again, we're going to just use the rules that we used before, and in this case, we're dealing with the fractions first inside the parentheses because the order of operations. So in the first set of parentheses, what's going to simplify here? We see the x and the x are common, so they're going to reduce. And also the y's. The power 1 is on top, the power 3 is on the bottom. So we're going to do the subtraction for the denominator. And here we're going to have 5 over 2y to the third minus 1, because the 3 is greater than the 1, so we're subtracting from the denominator. So this is to the negative second exponent, and we have here 6. And here again, the x is unique. There's nothing like the x, so it's just going to stand still. The y to the third and the y to the fourth, the third is smaller than the fourth, so again, we're going to subtract from the denominator. So here we have 5, y to the fourth, take away those 3 from the numerator. And this is also raised to the third power. So what's going to happen here in the result? Let's simplify what we have. We have 5 over 2y squared raised to the negative second, and here we have 6x over 5y's. And that's just a singular y power, all right? So this is to the third. Now, this is going to reciprocate. So our first step in expanding this is going to be to reciprocate the insides. We get 2y squared over 5 to the second power. And here we have 6x's over 5y's. And this is to the third power. Now we're just going to use the principles of the properties of exponents. And here 2 to the second power is 4. Y to the second times 2 because the exponents multiply when they're inside and outside. So this becomes y to the fourth. And 5 squared is 25. This is multiplying times the result of this exponent. So 6 to the third power is 216. If you don't know the solution, make sure you practice with a calculator to get these down and patent the ideas. X to the first power raised to the third, this becomes x to the third power because there's an imaginary 1 here if we don't see an exponent. So 1 times 3 becomes 3. And the denominator we have 5 raised to the third power, which is 125. And this is going to be also y to the third power because 1 times 3 is just 3. Now we're going to try to simplify the variables and the common things we have. Here these are some pretty big multiplications. I believe that's 3125 in the bottom and the top. I may just have to do this by hand. So here we have also, let's just merge what we have, right? So we have 4 times 216. That's going to be 864. And we also have x cubed and y to the fourth. And we're dividing this by 25 times 125. Now 25 by 25 is 625. That by 5 is 3125. And this has y to the third power. Now here we see that we have the common exponents, common bases, not exponents. The common bases and the higher one is in the numerator. So we're subtracting 3 from the 4 and we're moving it up. So our final solution is 864x to the third power. After we subtract 3 from the 4, we're just left with y to the first. This is divided by 3125. That takes care of problem number 6. So let's move our result here. Let's move on to problem number 7. Problem number 7, we have 2x cubes, y to the negative fourth, to the power of negative 2. And then we have 3x to the negative second, y to the fifth, and this is to the third power. Now usually we ordinarily begin with just what's inside, but for the case of the practicality of this problem, I'm going to convert this to a different form because it's a division and these are going to become fractions, right? So let's first rewrite our insides. So here we have 2x to the third, the y goes to the denominator of the first term, so this becomes y to the fourth to the negative second, and this is being divided by the denominator here. And here the negative 2 is going to go to the denominator of this pair, so we have 3y to the fifths divided by x to the second, and this is to the third power. Now we're going to write this in a classic way. This division line here just shows us that we're dividing two fractions. So we have 2x cubes, y to the fourth, divided by 3y to the fifth, x to the second, to the third. and this is to the negative second. So before we do anything, the order of operations, still we have parentheses done, exponents next, so we're going to flip, we're going to reciprocate this fraction. We get y to the fourth over 2x to the third to the second. Now it's a positive exponent, divided by 3y to the fifth, x to the second, raised to the third. Now we're going to evaluate each term, right? So before we do the division, we still have these exponents outside. So 4 times 2 here makes y to the eighth. Over 2 squared is 4. And x to the third, we multiply the exponent with the 2 outside. So that becomes x to the 6. We're dividing this with 3 to the third power, which is 27. Y to the fifth times the 3, the exponents outside and inside, multiply, that gives us y to the 15th. And on the denominator here we have x to the second times 3, which is x to the 6th. Now these are going to reciprocate on the second side because we're now dividing, right? So we have y to the 8th, 4x to the 6th, times x to the 6th, over 27, y to the 15th. All right, now to simplify this, we see the x to the 6 are common. Let's merge them together. We have x to the 6, y to the 8th, over 4 times 27 is 108. And this is x to the 6, y to the 15th. Now again, the denominator's exponent for y is greater than the numerator. We want to subtract the 8 from the 15. And the x to the 6 are actually common. So we could just get rid of these now. They reduce to 1. And we're going to subtract this 8 from that 15. So we could just get rid of this and put a minus 8 here. All right. Now we have 1 on top. And we have 108 y to the 15 minus 8 here. So we have 1 over 108 y to the 7th power. That's our solution for this problem, all right? Now, we have to be very careful. As you see, I use the properties of exponents in different manners when I did this, using the order of operations. That doesn't mean it's necessarily right? Now, as we see, everything goes to the denominator, so this is a good indication. Maybe there's a better way to do this, so let's take another look at what we could do to make this easier. And generally what I mean by that is, let's try to change the negative exponent to a positive one because it could lead to a quicker solution. So we have 2x cubed y to the negative fourth raised to the negative second. And we have this over 3x to the negative second y to the fifth raised to the third. Now the big problem we have here is we hate to distribute a negative exponent. Let's just move it to the denominator, right? So this becomes 1 over 3x to the negative second y to the fifth raised to the third, and this exponent is going to change to a positive from negative because we're moving it down. Once we transpose it, the sign changes, and this becomes negative 4 to the positive 2 exponent. Now we could just expand these by delivering the exponent to each term. So we have 1 over 3 to the third power is going to give us 27. And then we have x to the negative second times 3 is x to the negative 6. And y to the 5 times 3 is y to the 15th. This is all multiplying by 2 to the second power, which is 4. X to the third power times 2 is x to the 6. And y to the negative fourth power times 2 is y to the negative 8th. And essentially everything that you did before, and everything you saw me doing before in the last problem is now simplified through these steps. So let's multiply what we have left. We have 1 over 108, 27 times 4, right? 25 times 4 is 100. Add 2 to each multiplication. 2 times 4 is 8. 100 plus 8 is 108. X to the negative 6 times x to the 6. These two cancel out, right? Because negative 6 plus 6 is 0. Anything to the power of 0 is 1. And then we have y to the 15th times y to the negative 8th. We're going to add 15 plus a negative 8. They subtract, and we get y to the 7th power. And we can see how well using the properties of exponents helps us advance what we're doing. It just depends what road you choose to take. And sometimes that takes a little bit of work. Maybe you want to get somebody else to overlook what you're doing, all right? So let's get on to the next problem now, which is our final problem. And this one is going to have a combination of many different ways to do it. So we're going to pretty much stick to the rule you just saw because it works so well, right? So let's use this. Here we have 2x to the negative third, y to the fifth, raised to the second. We have x to the second, y to the negative third, raised to the third. And this is all over x to the negative fourth times y to the sixth, raised to the third. Here we have no problem because we see we have no negative exponents anywhere we go, right? And, oh, actually, wait, there is supposed to be one negative exponent here, right? Yeah, this is supposed to be a negative 3. So here we have our negative exponent. But that's not much of a problem. We'll just transpose it as soon as we begin, right? So this is going to come to the denominator. We have 2x to the negative third, y to the fifth, to the second, over x to the negative fourth, y to the sixth, to the third, and this is going to be x squared, y to the negative third, raised to the third power once we do the sign change, right? Now let's expand each term. So we have 2 squared here. That's 4. X to the negative third times 2 is x to the negative 6. Y to the negative fifth times the power of 2. That's going to give us y to the 10th. Everything here is over x to the negative fourth times 3. We multiply these exponents. We get x to the negative 12th. Y to the 6th times the 3. That's going to give us y to the 18th. And here we have x to the second times 3 is x to the 6th. And y to the negative third times 3 is y to the negative 9th. Now here we're looking at what we have. Let's combine like terms on top and bottom so that we can simplify it as much as possible before we deal with the division, right? So here we have the numerator standing still and staying the same. And we have 4x to the negative 6, y to the 10th. In the denominator here we have x to the negative 12 times x to the 6th. Our powers add and we have x to the negative 6 as a result of negative 12 plus 6, right? And the other powers we have are 18 minus 9, which give us 9. When we add these two exponents from the denominator for y, we end up with the power of 9. Now this is a pretty good position for us to be in. We see we have the same common term on the numerator denominator. Those divide to perfectly make 1. Those go away. Also, we see that we have a power of 9 on the bottom, a power of 10 on the top. So we're going to subtract the 9 from the 10. And this gives us a result of 4 and y over 1, which is just 4 y's. That's our solution for the last problem here. Thank you for watching.